Good morning, everyone. Welcome to this webinar. We'll be talking about model-based design for cyber-physical systems. And this is a joint webinar that's organized by three different entities. One is the Digital Twin Center that I'm leading, based on some money I got from the Paul Du Jensen Foundation. It's also organized by the Into CPS Association, and it's organized by the Hubcap Project that I'm the coordinator of. We have a program for you for the next 2 hours. I'm trying to record it, and hopefully we'll get a video out of that afterwards. But I haven't tried it for such a long meeting before, so hopefully it will work. In case you have any questions, please feel free to put them into the typing, the chat thing, or raise a hand. While the presenter speaks, he can't see those things, but Hugo and I will take turns in checking what is meaningful. So I'll start off by opening this webinar, and I will do so by giving this presentation where I'll give you a bit of context from a history perspective, because there's actually a number of model-based design research projects that we have had in a European setting. The first of those was called Destex. It resulted in a book and a tool called Crescendo. The second of those projects was a project called Compass, which was more on the system of systems level, resulted in another tool set coming out called Symphony. And then the Into CPS project that you will see some animations and some things from ended up in an open tool chain where there is a possible to kind of move the information from the different companies, or so the IP is owned by something called the Into CPS Association, which some of you are members of. And you'll see some more work about this and its co-simulation a little bit later. More recently, we have a project which is currently running. It's called Hubcap. It's having an aim of trying to make a cloud-based collaboration platform for assets for model-based design. And we have open calls for where small and medium enterprises are able to get funding for populating things in the platform. We'll also be able to populate things on a platform when you're not an SAP. Today, it's trying to demonstrate or are in the process of developing a sandbox capability that will enable you to sit in your own browser and be able to enable you to see the use of model-based design tools and the used models from different people. So I'll say a few words about this Hubcap project first, and it's a matter of trying to make a collaboration platform supporting model-based design, and then we want to be able to add both models and tools in order to make it faster to be able to develop cyber-physical systems using a model-based approach. Here we have a number of digital innovation hubs that are helping SMEs in trying out these things. And there's an opportunity with open calls, the first of them closing tomorrow, where SMEs can actually get funding for trying to add assets to this digital innovation or this collaboration platform. There is a plan which is not carved in stone yet, but trying to make this sustainable after the project is finished, which is in 3 years' time, by means of using a non-for-profit organization, just like the Into CPS Association is in a sense at the moment. So some of you may not have heard about co-simulation before, and essentially co-simulation is a matter of being able to combine simulation of different contents, different parts of a bigger system. And This can be by means of differential equations that are being interpreted, solved, or it can be discrete event simulators, and then you can cobble these things together, and this is what you'll see, one of the things you'll see today. Now, the elements that are in and around a cyber-physical system typically includes typically a physical part, which we call a plant. And then we have some kind of computer that controls that plant, able to do so based on inputs from sensors. And it sends out signals to actuators of the plant. Obviously, this is a simplified thing because you can have, in general, multiple plants, you have multiple controllers and multiple levels of these things. But in a sense, this is what's happening. Now, they will also operate in some kind of environment where the physical controller resides. And therefore, there's some kind of interaction depending upon whether you can measure the temperature for it, or you have other interactions when you have a vehicle going on some soil that is giving you some kind of friction. But you may not necessarily have sensors for all of these things, so you need to calibrate the models to fit for the real behavior. Now, the CPS project developed a chain of tools that was following a standard for this kind of co-simulation called the Functional Mockup Interface, FMI. And the chain of tools here, you'll see some of the tools today, others we'll show in other webinars. But the thing is that it's very much meant around being able to simulate different parts of your system, explore the possible alternatives you have using something we call design space exploration, and automate the test, which you're also going to see here today. This is one of the technologies being demonstrated. Just to illustrate to you what design space exploration means, here we have a very simple line following robot, and you see different colors of different robots because it's like we have been running different simulations and then place the sensors at different alternative places. So you see the orange one is very precisely following the line where it has the sensors placed underneath, and some of the other ones are more cutting corners and therefore not following the line as precisely, but they're acting more fast. And therefore it's a trade-off between, do you want accuracy, do you want speed, and you can make like a cost function to determine which one is the best one for you in your situation. So this was a kind of a, let's say, an easy kind of educational thing that we have, where we have these small robots. What you see here is actually a commercial product. It's called Roboti. It's developed by a company called Intelli, and they were one of the partners of the CPS project. What you see here is this autonomous robot moving over a field, and it's currently spraying on the field. And when it's turning, it doesn't need to spray any further in order to not pollute the environment too much. So this is now in operation. This is being sold by the company, and it's being commercialized further. And we will be using this, but we've been using this for our models and our simulations, but we're also making a desktop version of this, what you see at the top. And then there are pictures of 3 bachelor students who next semester will be trying to take this further and use this desktop version in a digital twin context that I'll come back to later. So what is happening today is that typically these development of cyber-physical systems involves a series of prototypes, and feedback is made on mock-ups or simple documents, and testing in the physical context can be rather expensive. This is where digitalization is creating disruption, and by means of combining these simulations together with what I call game engines to visualize things, you can actually experience a product before it exists. So what I demonstrate to you here is a product. It's a crane on top of a ship that is meant to kind of move a person from the ship over to an offshore wind turbine. But there can be waves on the ship, and therefore you'll see the crane moving up and down, but whereas the actual cast that the person is inside is not moving at all. We can use this with Oculus Rift glasses to get you the experience of what a product is like before it exists. This was made by one of our collaborators called Control Lab Products in the Netherlands, who have been developing this system subsequently on a commercial basis. Now, what we like to do at the moment in our digital twin context is we take multi-models like I've shown you here. We try to take operational data, feed it into what I call a digital twin, where we capture this in time format, we store it, we process it, and then try to enable decisions. The processing here is typically done by means of this cosimulation, but we're also looking into how we can use machine learning for some of this processing. Decision enabling can either be to human beings, or in case of autonomous system, to a kind of a supervisory control layer where decisions are taken either to update models or to deploy these things in the physical setting. And since we can have multiple of these digital twins, we envisage that we're going to have an application programmer's interface to these in general. So in order to kind of give you an idea of what we are heading at for the research group that I'm leading, we have a dream team of people, and you will see some of them here today, who are involved in the exploration of how can we use those such models in a digital twin context. So this is one project. In addition to that project, there is a project called Hubcap. And Hubcap you also see some illustration of today. And here we have other researchers who are complementing the first team. So it means that it's about basic models, basic digital twins. And now I'll show you some projects that we have been lucky to get facilitating happening in the remaining part of this year. So we have one called Made Fast. This is where we have more on the machine learning side. In particular, we need to find 6 new PhDs. We have hired 2 of them so far. So there's 4 posts being posted out there. And we have another project that starts next week, which is called Digit Brain. It's also about manufacturing, and it's about digital twins. So here we have 2 projects. They are already funded. One of them have started. The other one is starting the 1st of July. Actually, that's later this week. And here we have some other stakeholders. In this case, these ones are more on the mechanical engineering side. We have a new project that has started up, Roboti Fleet, where we have hired the postdoc, which is here, which is more on autonomy. And later this year, another follow-up project is called OpSim will start up, supported by ITEA. So the point here is that this is about digital twins in manufacturing, here digital twins for vehicles where we have autonomy based on things. Now, we also have a project running where the coordinator is in the picture there, and there's a PhD student as well, which is looking into digital twins for batteries. And finally, we have 2 new projects starting up later this year, which are about digital twins for buildings. And you see the PI of those projects from an AU perspective here. So there's a large team of people here, but in addition to the internal AU people you see here, there are lots of collaborators around the world. And you see some of those have actually visited us in January in respect to the digital twin project. But I envisage that we're going to have more of these webinars, and we're going to see more joint work between us and the other parties we collaborate with. Now, I also have 3 additional PhD students who are more free birds, so to speak. They can go and contribute different places in this palette of projects because they've been funded by other sources. So this is to give you an idea of where I see the model-based design heading just plainly from our side at Aarhus University. Now, this is actually, I'm now ahead of schedule, but the point is that I'll give you a few minutes to be able to ask questions here when before we go on to the demonstration. Hugo, that you just saw before as one of the internal people in both of the projects at the bottom, he is going to demonstrate that the Into-CPS application is actually fitting inside the sandbox from the Hubcap collaboration platform. And following that, Frank Seider from Verified Systems International in Germany will demonstrate, well, how can you move from model-based tests to co-simulations? again around this co-simulation setting in the into CPS setting. Then Nick will get online and try to explain how he has been making a checker for these units, the units that are used in FMI co-simulations called FMUs, and can be checking those that are out there publicly. And then Christian, one of the PhD students you just saw before, will be demonstrating a new Python FMU capability that he has developed, and Casper, also listed on the last page, one of the postdocs, will be presenting a new rapid FMU capability we have made in order to make it easier to link things up to the digital twin from the physical twin in this setting. And then finally, I'll give some closing remarks. So I'll stop sharing now, and I'll ask Hugo to start sharing, and then open the floor to if you have any initial questions, any of you. Any questions, anyone? We have at the moment, it looks like 59 participants. Any questions before we start?